In Swift, as with many languages, multiple classes can subclass one class, inheriting its methods and properties and forming a hierarchy of relationships like an upside-down tree. Imagine, for example, we want to set up a hierarchy of classes representing telephones using inheritance. Let's say at the base of the tree we have an abstract telephone from which all telephones inherit from. As all phones can initiate and terminate calls, let's give it these methods for make call and hang up. This would look something like this in code. Now, there are different types of phones: landline phones, cellular phones, satellite phones, shoe phones. For now, let's just add landline phones and cell phones to our hierarchy. They would both subclass the telephone class, inheriting its hang up and make call methods, and add any specific functionality of their own. For example, the cellular class might introduce a send SMS method. By the way, in code, these landline and cellular classes would look something like this. You can specify a subclass in Swift with a colon after the class name. A class can implement its own version of a method inherited from its superclass with the override keyword. Perhaps the cellular class needs to set up its own version of making a call on cellular networks. It would do this by overriding the makeCall method. This would prevent its superclass's implementation of this method from running. If you need it to run too, you can call it with the super keyword. Anyway, back to the class hierarchy. We might decide we want to break up these phone types even further based on their input technique. Old school landline phones can have a rotary dial, or there's push button landline phones, so let's create subclasses for these. Perhaps the cellular class could be subclassed into smartphones with touchscreens and non-smart with push buttons. Now, this inheritance model, which lies at the heart of object-oriented programming, is used throughout Apple frameworks and is a powerful way to show relationships between classes and share code, but it does have disadvantages that are worth considering. First, there are exceptions to this, but in most object-oriented languages, including Swift, a class can only inherit from one class. Smartphones aren't just phones these days, they're also game consoles, e-readers, video players, GPS devices, heart rate counters, fingerprint readers. The list goes on. With simple inheritance, smartphones can't inherit functionality from multiple superclasses. Second, code is only inherited between superclasses and subclasses. In the example, the push-button landline and the non-smart cellular both need to deal with buttons being pushed, but neither of them inherit from the other. In the pure inheritance model, they wouldn't be able to share common code without introducing another solution like composition. Third, sometimes it's just not so clear which identity is the most relevant to subclass. If we were to go further in our example, should we set up subclasses of smartphones by operating system or by manufacturer? Both are important and could potentially contain different functionality or properties. All of these disadvantages are addressed in protocol-oriented programming. This has been a sample from my video course, iOS Development with Swift. I've also written a book on iOS development. I'm hoping to upload a sample video like this regularly, so if you're interested in iOS development and would like to see more videos like these, you might want to click below to subscribe. Bye!